still
Hi,
hot.
well done, Jeff. Perfect timing. Hi, everyone, and welcome to another episode of Stump Jen. Thank you for joining us. With me tonight, I have everyone's favourite quizmaster, Dave the Critical Cripple. Hi, Dave. With me tonight, I have... Oh, I've got audio playing in the background, aren't I clever?
Just a little.
Highly professional.
I'm sorry to everybody out there. Where is that? Okay, I don't even know where that is. No, I haven't got
It's
audio
not
in the
playing
background.
anymore.
Okay, it's not happening now. Okay, I'm going to ignore that. We've got the wonderful Jenny Morgan. Hi, Jenny.
Mm,
Who's half asleep, but that's okay.
Good morning.
We'll forgive her. With a half a brain awake, she's quite functional. And the incomparable godless scammer Jeff. Hi, Jeff.
Hoi hoi.
Oi.
I see we've got a few people there in the chat. Not as many as often is, but I know it's rather early for everybody over there in the US, and stuff you because I don't like it too late.
Well, everybody's hungover from partying last night.
With Trump.
That our favorite bozo is off his Twitter.
I was going to say that the reason it's down is normally Donnie normally retweets Jen's stuff, but you know she's got the reach today for some reason.
Did you see Godless Iowan's tweet last night?
No.
Oh. On our last nerve starts in 45 minutes. Can someone please telephone Trump because he can't see it?
I love it. I mean, it is certainly a beautiful thing to have happened. It is certainly a beautiful thing.
It is indeed. He's getting what he deserves.
And then Google and Apple. I don't know if Apple have done it yet, have they? But Google has certainly gotten rid of Parler off of their. And Apple may be removing it from their app store. I don't know if they've done it yet, though.
But that doesn't keep people from using it that have the app.
No, it's just stopping it. It's slowing its growth, should we say?
So let's move away from the news of the world and let's look at some of the news of science, because science isn't judgmental and doesn't call for people to riot and things like that. So.
Okay.
So there's a recent paper about the states of matter for water. Now most of us, when we think of the states of matter, we think of solid, liquid, and gas. So you've got water, you've got ice, you've got steam. But of course, those of us here who are reasonably intelligent also realize you've got plasma at the far end of the temperature range, and down in the lower temperatures you've got Bose-Einstein condensates as well.
But there are more waters.
I'm sorry, I misunderstood you.
And how many of the
talking about states matter? I assume that we meant like Virginia, North and South Carolina.
States that matter. We're way past the election, Jenny.
Still got to make it about states' rights, haven't you?
Yeah.
I want to know how many matter states of water are there now?
There are two. There are now two states of matter for liquid water. So you've got your everyday water that we deal with. But when water gets up to between about 50 and 60 degrees, the properties of water actually change to the point where you could basically call it a different state of matter. The refractive index of light through it changes. Its level of conductivity changes. Surface tension changes. There was something else as well, and my brain's gone, what is it?
Well, I was just thinking states of matter with water because they just got 8.5 inches of water in the form of snow.
Wasn't it snow? In the form of snow,
in those states last night.
Yeah. Which is, of course, ice, which is another state.
No, that's bad.
Water. Yeah.
They should really consider buying a couple snowplows down there, though.
The really interesting thing about... Sorry?
Did you get your 6 to 8 inches last night?
That's
damn it, Dave.
It's too hot. Besides, Will is a long way away.
Yeah, but I heard he's really big, so
it's gonna be a bit more than six. It has to be a little bit more than 6 to 8 inches.
At 10,000 kilometers.
Okay. So basically, the importance of this find, as far as a different state of matter for liquid water, is that in the early Earth, temperatures were, of course, a lot warmer. So this makes a difference as to how life could have formed, because with different rates of conductivity in the water, different surface tensions, etc., it changes the way that organic compounds actually could come together within the water. So any furthering experiments we have to do with abiogenesis, etc., would have to take into account the temperature of the water as well as other factors as to what was in the Earth's atmosphere at the time and what was actually in the oceans at the time. So the temperature of the water makes a difference. It also makes a difference to us going into the future as our planet slowly warms up, and we may have areas of the ocean that or smaller bodies of water that get to these sort of temperatures, and it could make it difficult for life as it has evolved now to survive within the water.
Well, I can't imagine fish living in the north areas of the United States being able to survive at water temperatures above 70 degrees Fahrenheit.
Yeah. Well, I'm talking Celsius, not Fahrenheit here. So, so you're talking about quite tepid water here.
Oh, so you're talking about stuff 100 plus Fahrenheit.
No. Yes. No. No.
Yes.
Yes, I am.
35.
Sorry. You're quite.
35 is 105.
Yeah. No, you're quite right. You're quite right. Over 100 plus Fahrenheit degrees temperatures. So, yeah,
well,
you're dealing with quite warm, quite hot water at this point. But the properties of that water have changed significantly.
110 Fahrenheit is scalding to humans. That would kill us too. I don't.
Oh yeah, you wouldn't want to be swimming in this level of water. But there are small bodies of water that could reach these sort of temperatures with climate change. And whilst there are some bacteria and that can survive in those sort of things, and there are some fish that can cope with hotter waters and stuff like that, would they be able to cope with the changes in the dynamics of the water as well? So, especially as some of these changes that happen can start happening under certain conditions at lower temperatures, like when you've got different levels of pressure and stuff like that. So it's an interesting thing to find that the water is not just one state of matter, it's actually two separate states of the matter. We already knew this was the case with ice. There are several different types of ways that the crystalline structures can form in ice that actually give different properties to the ice, so they're almost like multiples. That they actually name them as different types of ice.
Ice.
And not all of those types of ice actually form on Earth, can form naturally on Earth. So it's kind of interesting.
I think the best way to think about carbon, because it's common.
Yeah.
So you have the different states of carbon.
Yes.
That are basically identical apart from the structure.
Yeah, like you've got diamond and you've got coal and then you've got carbon fibers and graphene. And they're different states for the carbon to be in. So thinking of matter in the normal 3 states of matter that you learn in high school is not in any way close to accurate to the states of matter that we actually know of in science. So it's just kind of interesting.
What would exist as liquid carbon? I mean, we know carbon as a solid. We know carbon as a gas.
Yeah.
We don't really know.
Yeah, there'll be a liquid form. I'm not sure what the temperature of liquid carbon is.
Can carbon be a liquid?
Probably not at Earth pressure, because I think it sublimates straight from
4,500 Kelvin. That's at 100 atmospheres.
Yeah. So yeah, you have to have more pressure to stop it sublimating. So going straight from a solid to a gas.
Yeah, it does. I mean, first one I come up with there, it says despite carbon status as quotes the element of life. Its liquid state is still a mystery.
I don't think anyone particularly cares. Everyone wants hydrogen.
Yeah. Yeah. I mean, the thing with carbon is it's a very fine line between the amount of pressure you have and the temperature you have it as, whether or not you can maintain it in a liquid form because it sublimates so quickly. So, but I mean, every matter would have every element has a liquid form. Well, every compound has a liquid form, as well as a solid and a gaseous.
It sounds like what it means is that carbon has a resting bitch face.
Okay.
Sounds like an attitude, no problem.
Carbon, you won't let us make you into a liquid. How are we supposed to inject you and get high? That's dreadful. Alright, let's move on to what I think Dave would be interested in. Okay, do you know about MOND, Dave?
What, modified Newton dynamic? Modified something Newton.
Newtonian dynamics. Yeah.
Yeah. No, never heard of it.
Never heard of it. Basically, it was a theory, a hypothesis. I won't say theory, it's not proven. Put forward as an alternative explanation, so we don't need dark matter. It modifies gravity at the distance level, so there's a slightly different effect of gravity over distance than the square distance law. It also allows for you have to equate in more interactions from further objects that are further apart from it. This led to predictions of what's called gravitational tide, which isn't predicted in either Newtonian or general mechanics or general relativity. The thing is, in a recent set of studies that was published in the Astrophysical Journal, scientists have actually reported minuscule discrepancies in the orbital speed of stars that reveal almost non-existent gravitational effects, which is partly what's it's basically saying that they've seen what they think is this gravitational tide effect that is predicted by MOND. It is the first time that we've actually seen something that was predicted by MOND in the data, which isn't predicted by other models, which is a good sign for MOND. However, there are things that are predicted by general relativity that we know we have seen, which aren't necessarily predicted in MOND either. Well, so MOND has the entire fight uphill to prove itself.
MOND was never meant to be. The point is, MOND also has a set of calculations now alongside it to make it relativistic.
Yes, it does. So basically, MOND's just a modification of Newtonian mechanics or general relativity that states that gravity behaves in a slightly different way to how we thought it did. Getting those equations right and balanced is the problem with MOND, and it's not it hasn't necessarily been shown to work. But this is a good pointer in the direction that MOND may be right in its premise that dark matter doesn't actually exist. It's just a misunderstanding of ours and the way gravity actually works.
It kind of sounds like to me, and I'm sure my flat earther friends would agree, that once again you're moving the goalposts, and just by making all this stuff up, you're proving that gravity doesn't exist.
Friends.
Yeah, you've got flat earth friends, Jerry.
Yeah. We go to bars and stuff together.
You take notes of this because you're going to call into Oakley's show later with all this.
Okay, never again. Theories are higher than laws. Laws are your separate. Yeah. A theory is
incorporate laws.
Sorry, what was that, Dave?
Theories incorporate
laws.
Yeah.
Yes. So
theory is more of an explanation of a body of work.
Yes. The laws are like your individual thing, are individual things that happen in nature that we express, say with a small equation or something like that. Theory is the body of work that explains that. So theories have a higher level to them, as I would. No, my mouth does not want to work today, which is unfortunate for Will. But yeah, so when we say theory in science, this is the same thing that we explain to young Earth creationists. We are not talking about a guess. Theories in science are backed up by a body of work.
Yeah.
They are the description of reality as the evidence shows at the moment. Theories can be disproven. They can be They might need to be modified at some point because we find something else out. An example of this would be if the modified Newtonian dynamics term pans out to be true, that will be a modification to general relativity. It doesn't mean general relativity is wrong. What it means is that theory was an approximation of what is right. And in science, quite often, when you're looking at the bigger picture, everything is an approximation of what is right, because we slowly creep closer and closer and closer to the truth of it. But we may never get there. There may be things we could never know because we're living in the wrong point in history. So, but we get closer and closer to it. So the theory, is the body of evidence that's closest to the
just
ultimate
point
truth.
something out as well. Just works just on Neverend's comments. I don't know quite if I've got this right. Science in itself doesn't necessarily deal in proofs so much.
Apart from the fact they call them proofs, which I find confusing.
Yeah, it confuses
proof, but it doesn't mean it is proof.
I think you got to understand. I think basically is there's definitions for things within science that are different from a sort of the way we colloquially would define the same words. It's but it's like when we're going on to what Jen was saying a minute ago. This is perhaps where again a lot of Jenny's flat Earth friends that she's on about get a little confused though, because for example, if the Mond is found to be valid, that to them the way they would take that is that Einstein's relativity is completely irrelevant. The same way that they view Newtonian physics is completely irrelevant.
Mond will be scrapped. Mond will be scrapped within weeks of having something confirmed in it, because they will work out how to reintegrate it into general relativity.
General relativity will never be scrapped. It is too well proven a theory. It may and probably will be modified at some point. And it is modified over time anyway, because as we get more information, the theory is changed to fit the information that we have. So science is dynamic. We don't just come up with a theory and say, that's it. We keep studying and we learn more and more and more. So the theories that we have are the closest explanation to the absolute truth of things in science. And
right, before it goes off my screen, I have to answer Fred Knotts.
Yes, I was going to do that, but I'll let you do that.
Mond in no way, shape, or form makes any predictions about dark energy. I mean, dark energy and dark matter are so completely different things.
Yes.
There's no predictions there, I don't think, in Mond. Mond is only describing what we currently see, and not the expansion of the universe.
The thing there's a significant difference in the concepts of dark energy and dark matter. The concept of dark
energy is purely mathematical right now.
Yes, dark energy is purely mathematical.
In the sense that the observation we have is the universe is expanding by this amount, by this speed.
Yes, we have to have a reason for
dark energy is the amount of energy it would take to make it expand at this speed.
Yeah.
And we just don't know
where that energy is coming from. It. Yes. Now, dark energy could itself just be a gap in our understanding that would be that comes out ends up being a change in the way we do general relativity, and that's
dark energy
highly likely.
Dark energy could just be drag.
Yeah,
that's how weird it could just be that the universe has an ether, an equivalent of an ether, right? That was slowing down the expansion, and as it gets further and further apart, that drag gets less. So the speed increases.
Yes, Fred's point.
What about conservation of energy? Why would it increase speed? What's pushing it further to give it speed?
No, she wouldn't get faster. The speed because there was more energy in the initial. Okay, I just made up this theory in my head, right?
Well, you'll have to do a better job.
Right, you made up this hypothesis in your head, Dave.
Yeah.
The point is, my point was I was trying to explain that the phenomenon we see could have numerous explanations.
Very definitely.
All right.
Even down to the concept that the one-way speed of light might not be the same as the dual direction of light.
No, you can't go there. You cannot go there.
Because you can't prove it.
I'll make you explain it.
You'll make me explain why we can't prove why the one-way direction of light, speed of light it could be different.
I have this theory about gravity that it's.
I watched Mike Merrifield fail.
It is a really hard thing to explain.
Wait, don't you want to find out what gravity is?
Go
on then.
All right.
Yeah.
Now they keep talking about this being the fabric of, space, and always do these little basketballs and stuff, stretching and all that kind of junk. Throw it all out. You know how water you got a glass of water there and you put a couple of say little poppy seeds. Room temperature. And you put a couple of poppy seeds in there, how they will draw towards each other and come together because of the surface tension of the water.
Yep.
Well, I think dark energy and dark matter are nothing more than the surface tension of the water of space, not the actual water, but that.
So you're going with an ether explanation?
No. Dark energy and dark matter are objects within the vacuum of space.
You've read this somewhere.
No, I haven't.
I've seen something along those lines.
No, I haven't. I'm making this up as we go. I'm not capable of that because I'm.
No, it is. But there was a paper written about this, and I think it was called the Elastic Universe.
Elastic Universe. I don't know. Wait, there's something nagging in my head. You've triggered something.
I've heard of that.
It has to do with matter because we know that matter stretches space-time, but what if it's not just stretching it, it displaces it, and that creates a tension within space-time, and that could be what's pushing things apart, as well as gravity, the displacement of it pulling things together. So the difference in that tension between the way that space-time is bent and the compression of it itself is what's causing the expansion of the universe. It could also account for what we see as dark matter. I'm not too au fait with this because it makes an awful lot of assumptions about empty space.
Again, I have a question. Why did inflation slow down and then speed up again?
Yeah, this is my problem with the concepts at the start of the universe, because there would have to be a driving force for that. And, we're also not exactly sure. The problem is we have this model of inflation. Sorry?
Inflation rates change based on what the Federal Reserve is doing with the interest rates.
Yeah, exactly.
Dan never again wants to know what I meant.
Okay. The whole reason we have this concept of the early inflation of the universe is to overcome the problem of the homogeny of the universe. So if the universe is going to be homogeneous, it had to be at some point early on very, very close together so it could maintain homogeny but expand very quickly to keep that homogeny. That is why we think we had ultra-fast expansion at the very beginning of the universe.
So
However,
you're saying the universe
isn't quite as homogeneous as what we originally thought it was. And even the rate of expansion across the universe is not consistent in all areas of the universe. So it is conceivable that the concept of
you're saying that
wrong.
You're saying that the universe is gay?
Okay, very, very probably. It's got black holes.
Sandy, the point is right now, our current model of the universe says that we started very small, we very, very quickly expanded to the size of a grapefruit, then we slowly expanded a bit, then we quickly expanded, and then we slowed down again, and now we're speeding up.
Yeah, and
we can't explain any of that.
Yeah, except we only think that happened to maintain that thing of homogeny across the universe.
The word you're looking for is ice or something.
Yes, I know there's a word, and my brain can't go there. But that's what that's what it talks about. Yes, I don't know.
I like the idea that it might be something like the Higgs, but the way they describe the Higgs boson, that it could be energy level.
Yeah, I mean, it could also be that the energy rates in the universe when it's different sizes are different because the field effects that that creates things like the Higgs boson, and that are different in universes of different sizes and temperatures, so that the state of the universe is not just as the side is fluctuating, but the actual to some extent at different sizes the laws of the universe could be slightly fluctuating. What we consider constants now may not have always been constant. But it's one of those things. It's really hard to know. As far as we can tell, looking at the universe, the laws of the universe are consistent, but it is very hard to know. And we come from a state of assuming that to a certain degree.
Yes.
Because we have to.
Are we in a void?
Yeah.
Are we in a void? A super void.
A super void. Is our universe just one of many within a super
void?
No.
Is our position in the universe a void? There's been several papers about this because it would explain potentially where a lot of the missing matter is. If what we can see in our part of the universe contains less matter than normal, it could also explain different expansion rates in different parts of the universe. There's several things. I think it's a super void, but that's stretching.
There are lots of hypotheses about what is causing the expansion of the universe. And it's conceivable that we are just so early on in a very young universe that gravity just hasn't had a chance to slow it down, and there's an awful lot of matter that we cannot see. That
doesn't explain it speeding up.
Well, it does. There's an awful lot of matter beyond what we can see. Because whilst we ourselves here aren't being affected by the matter that's outside of our visible universe, matter that's on the edge of what we observe can be.
I thought we proved
is. Sorry.
This is where I get to I don't know whether my knowledge of things is stuff that's predicted or whether or not it's stuff that's been observed, but I'm fairly certain that one's been observed.
Yeah.
I'm fairly certain we've seen things as well. I think we've lensed things that we shouldn't be able to see.
We've also seen parts of the universe that are heavily attracted to things outside of the universe, and we can tell that's a gravitational thing. So from that, it's quite possible that there's just so much extra matter to the universe that we can't see. That just like our galaxy is attracted to the Shapley supercluster, and then to the great attractor beyond that. There might be lots of even bigger great attractors beyond what we can see that is causing this rapid expansion of the universe.
So images of broken light which like dance before me like a million eyes. Is that what you're saying?
I feel like she's going poetry.
Well, we did have some questions that we've kind of skipped past. So Fred Knotts asked again. I didn't know if maybe dark energy could be affected by a different gravity explanation. In terms of what you first asked, it could be if our ultimately our theory of gravity has to be modified somewhat. That could affect how much dark energy there is, but it still doesn't explain why the universe is expanding at the rate it is. There's lots of other things that would have to come into play there. And a lot of it has to do with our vantage point to the universe. We just can't see out beyond a certain distance, and we can't see back into time to when the Big Bang happened and know exactly what this early point of the universe was like. We can guess at it, but we can't know, and that makes it really hard to extrapolate out from that exactly how the universe should be behaving.
It's one of those things we just don't know. But we may do one day.
Right, we've got Vesta one. New theory: birds are fake. COVID-19 is a plot by lizard people to keep us inside while they change the batteries in the fake birds. Last time they did this was during the Spanish flu. Well, if that's the case, they're not going to need to be changed for another several hundred years with battery developments.
So birds are fake. Where's the bird flu coming from?
We've got
dinosaur flu.
Why can't we harvest the birds and turn them into batteries for our cars?
The
lizard people don't want us to have.
Do you know? Ironically, though, I mean, even though I'm sure that's even though that's said as a joke, it's probably not the daftest conspiracy theory I've heard this month. To be fair, so you know.
Okay. Fred Knott's question was, if an object has a certain amount of initial force on it and the gravitational effect on it lowers, would it speed up?
Yes.
No.
Maybe.
That would... Well, look, it would slow... If you've got put a certain amount of force on something and you've got a gravitational force acting on it, that would ultimately start slowing that object down. Unless, of course, the gravitational force was in the other side, in which case it's slowly speeding it up. So if it's on this side of it, and it's been speeding it up, and you lower the gravitational effect of this thing, then this object is actually going to slow down because there's less gravitational force on it. If it's here and it's slowing it down to start off with, all that's going to happen is it's going to slow down at a different rate.
Yeah.
So no, it's not going to speed up just because you lower a gravitational field. If you increase the gravitational field, it might.
But if you're thinking about a rocket, it would because it's continuing to accelerate.
Yes, but if you've just got something moving at a given speed, it's at a given velocity, and it's not accelerating, then no, it's not.
This is really getting way too heavy for me. I can tell that I'm clearly at my limits. I need to substitute my brain. Could you hold on a moment, please?
You think this is getting too heavy for you?
No, I just need to call in a temporary replacement. You know, like a pinch hitter.
I'm sorry, Vesta. Yeah. I don't think I was paying enough attention to your initial comment. The one that Dave read out, I assume it was.
Yes.
Yes.
If we've got another Fred Knott's question.
Yes.
Anyone wants to give us non-physics questions after that, then we'll save Jenny and Jeff.
Okay, so what was the new question, Dave? Because I think I might have missed it.
I've lost it. Where the hell's it
gone? In the early universe. That one.
Yeah.
That one?
Yeah.
In the early universe. You can read it, yeah.
No, you go. Sorry. Our lag is terrible.
It is.
Go.
Alright. In the early universe, when subatomic particles started bonding to create particles, were they all blinded? And if not, what happened to them? Oh, binded, not blind.
Binded.
What happened to them? In the really early universe, nothing. You basically had quarks and leptons floating around in free space. It took a long time for the universe to actually cool down enough that you could actually have protons and electrons and neutrons actually form from the fundamental particles. Electron is a fundamental particle. Sorry, there were already electrons. So once that had happened, and then the universe got a bit colder, then these particles that were moving around slowed down, and they could start actually forming into hydrogen and helium. So it actually took a long time, and not all of those particles would have been bonded.
No, most of the particles that were subatomic they couldn't survive away from each other.
No,
your quark. You're basically talking about quarks, and they as soon as they either bound together or they're destroyed. They decay.
Yeah, so I mean, when we're talking about times in the early universe, you're talking about a really hot, dense area, and this in time has a lot less meaning when you've got a hot, very dense, very, very tightly bound amount of energy in one location. Yet time changes like it does in the middle of a black hole. The only reason why the early universe didn't collapse back in on itself was the amount of energy that was there was enough to overcome the force of that. So the gravitational force that was caused by all that energy in one location was also overcome. Plus, there's a strong possibility that the reactions of the Higgs boson and the way the energy bent an early very small space time was very different. So it was when you had a smaller space time, the ability to bend that space time wasn't as great. So as the universe is stretched out, it's actually become somewhat easier for space time to bend. That's not a confirmed thing. That's just a hypothesis. It's one of those things that goes when you're trying to talk about the early universe. It's very hard because we don't know the exact state of the really early universe. We know it was very dense and very hot, and we know that certain things couldn't have formed during that. We also know that it cooled down very quickly as well, down to a point where you could have you could have protons and electrons form. But in our terms, it was very quickly. But in terms of the universe itself, it took a really long time because you're dealing with a very small universe.
And I like the fact that for the first 300,000 years, that it was like being inside the sun.
Yeah,
it's the closest analogy and analog that we've got.
Yeah, even after the first after the first 5 to 600,000 years, the temperature of the actual universe was such that particles had started to form, and oh hi Chad.
Hello. Sorry.
Good. I can rest my brain.
Yeah. I wasn't paying attention to what was going on in the chat. Sorry, or the stream. I was getting in an argument with some idiot on Twitter, as you do.
It's okay.
I thought they kicked him out of Twitter.
What are we talking about?
What are we up to? Where were we up to?
There's
Dave,
plenty of idiots out there. Don't worry.
The universe was in a hot, dense state.
Yeah, the whole universe was in a hot, dense state.
That brought me up a question in my head. How do they keep saying that? Oh, the universe was small and it was all this matter or energy crammed into the size of a basketball or something. Well, how do they? Well, that's what people don't believe. Is that how could everything?
Yeah,
fit
it might not
space?
It might not have been that size.
How do we know it wasn't the size of our solar system?
Because we can reverse the sums that we've got now. Yes. You know how fast everything's moving apart, and we can play it in reverse.
But we don't know how much matter is out there.
Well,
we don't.
But here's the problem, though. When you're talking about like the Big Bang, the thing that really kind of is the brain fuck is realizing that it's not a basketball. When they're talking about when they're talking about everything we see coming from a particular dot or what have you, they're talking about our observable universe. That instance in the continuous sense of like real numbers, that particular instance is what gave us our universe. Yeah, but here's the thing: in the part of the same structure, just because we can't observe it, the part that was right next to us continued to expand as well, and we know nothing of it. Yeah, I mean, we have no reason to believe it has other properties.
When we talk about a singularity, which they don't, they talk about pinprick. If we say our visible universe was a pinprick, that does the start.
But
the universe could still have been huge.
Well, that's the thing. The universe has always. We have no reason to believe the universe is not infinite. I remember attending a talk on this a few years back, and we were talking. It was a theoretical physicist, and he was talking about the early universe, and quite literally on his slides, he said, "Here be dragons." They have no idea what the hell is going on. So, what's important to note is when we talk about the singularity is for the universe that is us in some sense.
Yeah.
But when you're talking about the Big Bang, you're talking about space itself exploding, which happens everywhere simultaneously.
Yes.
So you can't use what is in your mind as an explosion as an image of what this means for space to begin to exist and expand.
Yes.
Our mind can't convey that. It's just the best analogy we have.
Yeah.
So at the end of the day, everything exploded everywhere all at once. The Big Bang was bigger than you think. It wasn't when you think singularity.
No.
That's what the mathematics does when we bring it back. The mathematics is the best model. The best model. I mean, again, here be dragons. When you start talking about the early universe, you're talking about things where we just don't have the information.
Let's see, I'm trying to remember what the concept's called in quantum physics. Where this atom does something and this one way over there does it at the same time.
Entanglement.
Yes, entanglement. That the whole place blew up all at once because of entanglement. Maybe
it's okay. Let's try this. Okay, I'm a very visual person, so in your head, just imagine. Well, I kind of do, but
you are
in your head. Just imagine
you are cute. That's true.
You know that in your head, imagine an explosion, and you also have in your head this general relativity image of like this mesh of space-time, right? We both have those images in our heads. Yeah. So if I say, you know what an explosion looks like, and you know what space-time looks like, don't worry about putting them together yet, but you can kind of do that in your head, yeah?
Okay.
Space-time, you got this grid, it does this weird bendy thing, you put the moon in, stuff circles, all the bad animations you see online. You got that in your head, right? Yeah.
Okay.
So if you have that concept of space-time in your head, what you then have to do is take that grid, and again, all the matter exists as points on the grid, but the grid itself goes. So it's not the matter coming in on itself, it's the grid itself collapsing. So the problem here is not trying to explain how matter exploded. The problem is trying to understand what the hell space is, and that's what we don't understand. That's the pit, because we don't understand how space itself can, because regardless of where those things are in space, I mean, we kind of do this in reverse when you're talking about current galaxies now. We see them moving away from us in space. So we kind of interpolate that backwards. But that's the space itself moving. So if you think about that grid, those galaxies aren't sliding along the grid. Those galaxies are pinned on the grid and sliding. And the grid itself is moving.
It's like blowing up a balloon.
So when you're talking about exactly, that's where that kind of analogy comes from. But the problem is, stop thinking about the matter. You have to start thinking about the space itself. And matter is just stuff that happens to happen in it. The space itself is what exploded. And you can't get your head around that. Our monkey brains don't do so well. But that's what the mathematics says.
Especially as all the examples we get given of space-time, we're showing it in 2 dimensions. And space-time is a 4-dimensional
I've seen it in
phenomenon.
3 dimensions. I've seen representations in 3D, and it's awesome. But
it is, but space-time is a 4-dimensional thing, not even 3-dimensional. So it's really complicated to think of because it's your 3 physical dimensions and 1 of time, and you've got to allow for the whole lot of it if you're talking space-time. So the universe is in 4 dimensions, and we find it really hard to think in 4 dimensions, even though we exist in 4 dimensions.
Well, exactly. Well, the problem is we use the word dimensions and we don't know what the hell they mean. And again, that's kind of talking about if a dimension's a thing, can you put it in a bucket? And if so, how can I make one? Right. So it's a label we've put on a concept, but it doesn't mean it's an object.
That goes with one of those. That goes to those realism arguments of numbers. You know, that's similar to that, where people argue, are numbers actually real extant systems, or are they just ideas that we came up with?
If you want me to go into that, I can. But
I'd love to, but we won't do it tonight.
I want to point out that you've all gone wrong here. Okay.
Okay, Joe.
Finally, some sense.
Okay. In the beginning, when God created the heavens and the earth was a formless void, and the darkness covered the face of the deep. And while a wind from God swept over the face of the waters, then God said, "Let there be light," and there was light. There we go. See,
and then a bunch of incest, and then
yeah, and the rest is history. You know.
No, that's completely wrong.
Microraptor string theory. Let's go somewhere that I am not anywhere near good at.
I don't understand it. I don't pretend.
I have.
As far as I'm concerned, it's mathematical masturbation.
Yes, that's how I look at it too. It's like we have a problem in that we want to join all the physical forces together and have this grand unified theory. String theory is one way of trying to achieve that, and we do that by making up all these extra dimensions that we have no way of proving exist or not exist.
Exactly. Can you put it in the bucket, please? Like,
yeah,
is it
it's
what is a dimension?
It's brainwank. It is pure brainwank.
Yeah.
I can think better than you, so let's. There's no way you can prove any of this. I would much rather deal with the science that we can go out, we can observe things, we can learn about, and we can do it rather than these hypothetical things in string theory, which we don't maybe necessarily need because we've had some movement in the direction of unifying quantum mechanics and general relativity without needing string theory. So
through quantum gravity and other things,
yeah.
But again, here's my big. Like, I'm a science teacher. You know, you guys know me. Here's my big thing. The universe is under no obligation to be intelligible to us.
Exactly.
Everybody has this conceit that we can understand. What we can do is we can build our best models, interpret those models, and try to spin them to come up with other models. In the same way that you kind of need to draw a picture to play with when I was playing with my hands earlier, talking about space expanding versus things moving in space. You need a way of kind of bringing these ideas together, but it's not necessarily representative of reality. At the end of the day, we only have maybe 80 years on this planet to get our monkey brains from, sucking on mama's tit to somehow being smart, right? I mean, at the end of the day, science is an abstract thing beyond us of continued models. It's not. It's a means of accepting. As far as I'm concerned, science is accepting that truth is unknowable and that the universe is unknowable, but we can still function and control things within it. That's kind of my thing.
By the way, Chad, just to point out, one of Sassy.
I'm pretty high right now.
Sassy Heathen, one of your fellow Canadians, she's trying not to fangirl over you right now, sir.
In the chat.
Yeah, I think you've got a fan there.
Going on from what you said, Chad, and the mathematician in me is going to be screaming in a second.
Hold on.
The tools we have.
I got a mathematician over, not yours.
One of the greatest tools we have as people who love science and everything is maths. It is the tool that we use to describe the universe. However, maths is our construct.
It is the language of reasoned thought.
Yeah, but maths is also our construct. We have no reason
it's a language of reasoned thought.
It's a language of reason. And we don't know that the mathematical equations that we use properly represent how the universe is. The universe is under no obligation to us to fit our mathematical models. They just seem to approximate it. And this is part of our problems. We get closer and closer to a good approximation of how the universe works, but we are probably never going to get there. There are elements, there are things that happen within the universe that seem to happen in a completely random and unintelligible manner to us. And it is quite possible that we will never be able to get to those bits of data of the universe. Heisenberg's uncertainty principle tends to suggest that is going to be the case. And because of that, we may never have proper equations that fully map out exactly how the universe behaves. And to add to that, the universe is under no obligation to be consistent. It doesn't have to behave exactly exactly the same right now as it does
It's been pretty
now.
good. It's been pretty good.
It's been pretty good, but we can't guarantee over the long period, especially as we are in such a young universe right now, that those things will remain the same.
You're starting to sound like a young Earth creationist, by the way.
Yeah,
And how do you know it's a young
but
universe?
young in the fact that our universe will probably last for 1 trillion years, and we're at
If
13.77 billion years now.
If it's the only universe we know, how do you know it's young?
Our universe,
Okay.
as in
Now,
our Big
we have to
Bang.
define universe.
Our Big Bang. Our,
Well, that's
our,
okay. Okay, so
Because
the Big
we've
Bang
defined
associated
when
with the local
time
observable
starts.
universe.
the
Got
local
it.
observable universe is 13.77 billion years old, as plus or minus 40 million years. Sorry.
The part of the universe which we are in appears to be 13.7 billion years. Yes.
old. Which is
We don't know anything
Fine,
about
I can-
the part
I
of the
can accept
universe
that, but how do you
potentially
know
next
that's
to us.
young?
I've carbonated
Dragon
this rock and
again.
it's only 50,000 years old.
Calling it young, though, makes it relative to something else. How do you know it's young?
It's young in comparison to how
Oh.
long we conceivably think it could last for.
Generations of stars.
Compared
Yes.
to infinity.
Well, no, the
A
universe.
lot of things are young compared to infinity.
A universe
okay with
that's
that.
a
I'm
functional
okay with that
universe is
definition.
probably not infinite. A universe that is functional from our perspective is probably only going to be a couple of trillion years. Tops. It may be even less, but it's still going to be
I choose not
lots
to
of
be mad at
billions
that,
of
okay?
years. So, a lot more
Yeah.
years than it's already been. So we are very early on in our visible universe.
So it's
Yeah.
likely that I'll be able to pay off my house before
The universe ends. Yeah.
the universe ends. Okay.
There are scenarios
That's
where
all.
we end the
Uh,
universe in the next second easily, depending on exactly what the nature of the universe is. But they're very, very hypothetical. It is more likely that we're living in a universe that will last for 1 trillion or more years, and that's a bloody long
And the
time.
bad news about the house is that there's more dollars associated with debt than there actually are dollars in the economy. So all things being equal, now you're going to die in debt, and that's fine because debt doesn't get passed on. So live it up.
That's why,
Just saying, they can only take your debt from your estate. So just make sure you own nothing when you go.
Yeah.
Well, I'm
Either that or live
I'm
forever.
on that road real well. I made the map
Is
on
that the
road.
reason why they're looking for ways to extend life so they can extend debt?
Mm-hmm.
I mean,
Well,
it's gonna be
Yeah,
gonna be here long after we're all gone. I mean, as a species, you know.
oh, hold on. You see, now you've got an interesting thing here. In a world where everybody can live forever, potentially, wouldn't death then become a celebration of somebody deciding to conclude their lives? So it would actually be more like a wedding than anything else in that case, if you're thinking distant future. But that's kind of a high thought. So
I
I'm
would see
people are
it
pretty
more as
touchy about
people,
suicide.
in
I'm
the
working on the
future, people
assumption-
choosing to download their consciousness into a virtual world would be the point of celebration.
Admittedly, I'm working on the assumption that our species has got about 10 years left. So,
Yeah, well, us don't have trillions of years. Our universe does. Even our planet doesn't have trillions of years. We're at top best. We've got another 5 billion years or something. And not all of that's going to be livable on this world because the expansion of our sun happens before then in the next 3 billion years. So
yeah.
and it's going to get
Yeah, we'll
warmer
be out here
even
by
leading
then, I'm
up
not
to
worried.
that. So what is it? Conservative estimate is about 2 billion years of a sustainable life on Earth, assuming nothing else happens.
yeah, something like that.
No,
Something in
no,
that region, isn't
less
it?
than 1 billion of water now.
Is
Yeah.
it less than 1 billion of
Less
water?
than
Is
a billion.
it? Is that the newest estimate? Yeah.
It could be.
And
it
we're
could be
and we're
less.
keeping
It
our
could be
borders
down to
closed.
a
You
few
can't have our
hundred years.
clean water.
I thought water was infinite with the cycle of water.
No, it'll evaporate.
Liquid water.
No.
Now, desalination is becoming a bigger thing, though, so that's the prices of that are coming down. So that's not becoming so much of a thing. There's a lot of desalination going on through the Middle East right now, but I think about a quarter or a third of the world's fresh water is in Canada. So if you want some,
Canada's.
I
There you
think
go.
I would like to
is-
do the calculation of how many gallons of water are locked up in human bodies.
it's going to be so in the basically in the
Minuscule.
future. Either in the future, Canada is either going to be A, the greatest global superpower, or B, your neighbours from the south are going to be coming in to spread you a little bit of democracy when water becomes the most precious commodity on Earth.
I live in the Great Lakes Basin, so I'm not worried.
Yeah.
You live
deal with
out
Jenny's
too.
question here, though. I want to deal with Jenny's question about how much water is tied up in people. If you think about how much gas is in every engine, like every gas tank in every car, plus the gas that's in the basically the entire petroleum supply. There's a lot of gasoline out there. Every household has at least, well, on average, basically one car with a tank full of gas, which is about, assuming half full, let's give it about 30 liters. That's basically a human, if you take the water out of it. I mean, it's on the order of magnitude. So if you want to know how much water's tied up, just look at the oil supply and you'll get, again, order of magnitude, but it'll get you the right number of zeros. It's not too much.
No.
Well, I think we should start harvesting people for water and put it back in the water column.
Oh, absolutely. Soylent Green, let's do this.
Was it
Absolutely.
2020 was the year that the amount of man-made materials actually exceeds the amount of biomass on the planet?
Ooh.
I was reading that today.
Where'd you get that stat from? Where'd you get that one from?
Yeah, I can't remember, but I read it today when I was looking up some other stuff. Yes, I know you want a source for that, don't you?
I always want sources. Well, okay, just give me a rough idea. Was it a news site? Was it a...
It was a news one. It was
science
actually
blog?
a news one. It wasn't a science journal.
Okay. All right. My bullshit meter's going down.
I don't know if it's a news site. That means they could have gotten 2 words and made it into a paragraph. None of it making sense.
I can't even read the news because you click on an article and about maybe 3/4 of it are summaries of what has happened over the past 4 years.
It was in
and then, like,
Nature.
a sentence
There you
about
go.
what they said.
Global human man-made
Nature?
mass
Okay.
exceeds all living biomass. It was published on the
Good.
9th of December in Nature.
Oh, wow. So this is kind of moving... Our robot overlords in the future will recognize this year as being significant.
If anyone wants to read that,
think it's
there's
the
the
best
link. You wanted a source, I went and found it.
No, that's fantastic. I love it.
So yeah,
Like I said,
we
it'll be a
actually make
significant
more
date for our
crap
robot
than there is living things on the Earth, and there's a lot of fucking living things on the Earth.
Yeah, but some are so itsy bitsy, teeny weeny, tiny. You can't even see it.
Oh yeah, but that biomass actually is a lot of mass. So the point is that we are making a lot of crap, and most of it is crap,
but look at how
and it
much
ends
crap
up
you
going
gotta
into
put
our
together.
ecosystems as garbage. So
Look how much crap you got to put together to make a human. And by the way, stop calling me monkey brain. I'm a primate.
monkeys are primates.
Yeah.
Oh, are they? No idea.
That doesn't sound right, Jenny.
I'm basically a shaved gorilla, so...
So we've gone so far down the science rob.
Oh, yeah.
Somebody want to throw Jeff a history question or a politics question, maybe? Because I'm sure Jeff would like a question.
No politics. No politics.
No politics.
Oh, I don't know. Trouble is now I'll be expected to answer it correctly. Then
Yeah, that'd be
I
awesome.
might not be able to do that.
Well, I'm trying to think of a history question or something like that now. Because I love this stuff.
Why is it 1066? Why not 1067?
Well, I don't know. Whenever the Normans decided to invade, I suppose.
And where did they get the name Norman?
Yeah.
Why aren't they the Ralphs?
Basically, I've just sort of come from Northmen, because they were Scandinavian in origin, not French. Yeah.
It's the Viking. I find it really funny they talk about the Vikings that raided from the us defeating the Vikings in the north, and then being defeated by the Normans, which were the fucking Vikings gone the other way.
That's right. Yeah, because you had the Battle of Stamford Bridge, didn't you? Where they Harold Hardrada, who probably, if you were a betting man, you'd probably bet on him to be the guy who come
at me,
conquer England. If you were a betting man back then, but you know.
Let's go with a weird one for you, Jeff. Where does
Spooky?
Where did the fake history thing come that idea come from that Columbus was trying to prove that the world was round?
I'm not quite sure where that myth came from, in all honesty. I mean, it's well known that
it is a really old. It's one of the older flat Earth things that that a lot of people
I think
believe.
I think it was an extrapolation of theories that I remember back in the 50s being taught that Columbus comes in 1492, that he was looking for spices from India, and that they knew that there should be a way to get there by sailing west instead of east, well, south then east, and thereby would prove that the world is round. As a result, that it wasn't that he intended to prove the world was round, but that it would, as an end result, prove that the world was round. Because
he'd be one of the first people to circumnavigate the world.
Yeah.
Yeah. He would be.
You see, I think these kind of myths tend to come from when we're talking about myths, especially in the modern age. The people who perpetuate myths are teachers, in some sense, because they are the storytellers that we basically give over. We basically they are the storytellers, the keepers of our identity, in some sense.
Like those biology majors in Alabama.
Well, that's the problem, is when people start asking, when people say Columbus discovered the Americas and such, because he was going this way, and then the student asks why, that teacher still has a lesson plan to get through. Their knowledge is incomplete, and they go based on what is common knowledge, which is somebody else's understanding of half facts. And that's when they get this idea that, he was doing it to see if it was round, to see if he could, rather than to... So it's just a bad phrasing becoming common knowledge.
India by going the other way,
yeah.
So it became...
it's
Chinese whispers. It's effectively a Chinese whisper.
It's a short journey to say... Yeah, because if I, as a history teacher, were to say he went west to see if he could... and then left it at that, suddenly the classroom now understands nobody's done it before. It must be because... So that's how they know the earth is round. The teacher didn't have to say a damn thing. They just had to give you that sentence fragment and move on with the lesson. Without context,
then that becomes, he went there to find the earth was round.
People start connecting the dots.
So it's
exactly,
yes,
and that's just
Chinese
somebody's
whisper.
headcanon, and then they assume their teacher told them that. Exactly. But the way we remember things is also kind of tricky, because when you get into the psychology of it, we remember our headcanon, and then we go back, my history teacher told me that. No, that's not what happened. Like, your own memory gets changed on that. Like, well, my history teacher told me. No,
we
you
all
left history
rewrite
class
our own
thinking
histories over
is a
time.
different thing.
Well, I think the fact that you even the fact that there is even a narrative to Columbus discovered the Americas when there were people who'd been living there for a long, long time before he got there. Says a lot.
It's an interesting thing though, that people still believe it today.
I really like the phrasing Columbian. It's common knowledge. That's the problem. Common knowledge. When people say common knowledge, it's all the shit that they just want to believe and assume everyone else does, because it's common knowledge. If I believe it, everybody must.
It's
never assume anybody understands a damn thing.
Well, I mean, really, what you
exactly.
think? Look, Columbus himself. What did he discover? It was the Bahamas archipelago, and then what's now modern day Haiti and Dominica. pretty much
Something
what
like
he
that.
discovered.
Yeah.
If you, and I'm using discovered that he was the first like Westerner to get that, find it. You know, it would probably be the.
Well, that's not even true because there's Viking settlements in Newfoundland going back to the 10th century.
Yes. Yes.
So the Vikings were here in Newfoundland long before Columbus came over, but they just didn't stay because if you actually want to get into the history of it, they didn't get along so well. The land wasn't all that great, and it basically went the way of Jamestown. But yeah,
The first citizens didn't really
from my understanding,
like them too much.
Yeah.
Mm-hmm.
So do we have any more questions from the
Pretty
chat?
much.
Or are we going to go down our own thing? Dave, do you have a question?
I'm not watching
for
the
us?
chat at all.
Do we even have?
Nobody ever asked. Nobody ever asked my questions for my
He's muted.
area of expertise.
What's
He's
what's
muted.
yours,
Oh, there he
Jen?
is.
You want something about cars or
No, I just was thinking general stupid.
general
That's
stupid?
all right.
You're not generally stupid though. You're
Yeah.
quite intelligent, you know.
Do I confuse which shoe is for which foot? That sort of thing. Sometimes. It would be
I
the
thought-
answer.
I thought that meant you probably had an encyclopedic knowledge of the amount of stupid that there is on the internet, because you do see a lot of it, Jen. To be fair,
Well, I memorized it.
yeah.
So, do we have any more questions from the chat? Because we are asking. So,
I'm not even. I can
If God
ramble
is
on.
not real,
I've got the gift of the gab, as they
why
say.
does my foot itch?
It's a
Checkmate atheist.
teaching is an edutainment industry. Teaching is an edutainment industry. You got to be able to keep going. You got to
Keep
be able
going.
to keep filling the air, keep them engaged.
Well, let's
Okay.
go back to because Dave and I was talking about
Do we have any more
the-
questions?
we don't does
Yes,
the
there
constant
is.
of light
There is
match
one.
the speed of expansion? No.
Expansion is much slower.
No. Well, it depends when you're talking about. The universe has expanded faster than the speed of
Yeah,
light.
very true.
I thought we reached our limit of how much we could see of the universe because of that concept.
Yes.
Because the universe has in the past expanded faster than the speed
An
of light.
interesting thing about the speed of light. Just a fun fact about the speed of light. You guys keep saying it's a constant, and it's really not. You know that's a derived quantity, right?
Yes. And we don't even know if it's the same in both
the speed of
directions.
Just a second, I got to take some Advil.
My apologies. So just so people know, the speed of light is actually, if you get Maxwell's equations, the wonderful set of equations that talk about electricity and magnetism and how stuff wiggles and jives. If you play around with those enough and mash them together in the right way, you can get them to look like this thing called the wave equation.
Yeah.
And it turns out that speed of that wave is 1 over, if I recall, the square root of the electric permittivity of space and the magnetic permeability of free space. So if you take 1 over the square root of those quantities, that's c. So the speed of light is related to, light itself is not the constant. How
No.
electric and magnetic fields move through space is constant. So it's a subtle distinction.
Yeah, so
But
the
an
speed
important one, I
of
think.
the speed of light in
People
that
talk
sense,
about light like it's a fantastic thing. It's like, no, it's just electric wiggles over there. Don't worry
which
about it.
means the speed of light is actually a property. The speed limit that people think of when we're talking about the speed of light is actually a property of space and not of light itself.
Yes.
Exactly. So that's why we use the permeability of free space in that case. If you
Yeah.
change it for the permeability of a medium that glass is traveling through, now you're just talking about index of refraction. It's
Yeah.
more or less the exact same
I find
wiggling
it
math.
funny we refer to the speed of gravitational waves as being the speed of light, which makes a lot less sense. But it's just because it's
Well,
the speed
exactly.
of
So-
background medium.
Well, it's interesting to know that gravitational phenomena move at the same rate as electronic and magnetic phenomena.
Which
That's
is
kind of
why
the
we think the
deeper truth
graviton
that
should
I don't
exist.
really understand.
That is the whole reason why in
Exactly.
quantum
So
mechanics we think
it's-
the graviton must
It's
exist.
there in the math, but it's not explained.
It's there in the math, but we've never discovered it. And it should be there, otherwise there is no reason why gravity should move at the same speed as everything else. But then again, that could just be a property of space-time itself as well. This is comes back to what we were talking about before, with not really truly understanding exactly what space-time is. We know it's a thing, but actually understanding space-time itself is what's complicated.
I'm just going to take a little aside. I happen to have my general relativity textbook here. I'm going to see where the speed of the gravitational wave thing comes from, because it might fall out from the equations. I'm not sure. I've never actually bothered to look into it.
Yeah.
Talk amongst yourselves.
Let's talk amongst ourselves.
But yeah, that gravity happens.
Shall we go back to the question of why is it we can't prove that light travels at the same speed in both directions?
Now you're making mouth noises. What are you talking about? What do you mean we can't prove it?
We cannot show that the one-way speed of light is the same as when you have as the dual direction of light. So like if you shoot a ray of light and bounce it off something, you can time how long that ray of light, or you can use the interference patterns to determine how fast light moved in that direction. What you can't know is if the speed in one direction, if that light ray traveled at twice the speed of light in that direction and half, a slower speed on the way back. You can't know that. There is no way we can possibly test it.
Oh, okay. So you mean along a single dimension?
Yes.
So like you're talking about in the positive versus negative direction.
Yes.
Okay. You see, at this point, this goes back to our bucket of dimensions, though. The dimension is something that you make up. So when you say this way, the universe doesn't give a shit.
No, it doesn't.
So
it really doesn't.
The fact that you say this way or this way or this way, the fact that you can do the experiment. It's like, okay, you're going to do a one-dimensional problem? Okay, here's your dimension. Give me a bucket of it, right? Like,
yeah.
That's something our brain is doing to help us with the problem. But yeah, I think the universe would have very different properties if it was asymmetric along a single axis.
I tend to agree with you. I tend to think that
like if I could
be
move
symmetrical.
left faster than I could move right.
But our problem is we can't prove it. Although I would.
But do we need to? Again, it's a question of. Sorry, go ahead.
The point is the math works regardless of whether it is or it isn't. And that's the problem.
Yeah.
And that's probably more a fault in our maths, the math that we use at the moment, than it is a fault in the universe or a weirdness of the universe.
Yeah.
How can they?
Well, exactly, because the math. Go ahead. Sorry.
No. Go ahead.
I'm just making noise because it's what I'm used to doing. Go ahead.
Yeah.
Oh, okay. I don't even understand. I mean, I believe that they do, and that it's accurate, but I don't understand how they can calculate the speed of light. If you don't have a stopwatch and you can't stand there and go click click fast enough, how do you measure something like that?
I've actually done it with a stopwatch. I've actually done this. So I've actually done the Cavendish experiment, and I actually did measure the speed of light. These are things, experiments I did in my undergrad. During our third year physics, we had to do an experiment and just design it from the ground up and do it. And I love fundamental things, so gravity and light are exactly where I went. The way we measured the speed of light is, well, a long hallway, a mirror on one end, and a mirror on the other. And we shone a laser at this one, and it would just bounce back, dink, and then it would reflect back off to some sensor on the side. Now, what's special about this experiment is we actually had a mirror. The mirror that was here was actually an 8-sided octagon. Every side was mirrored, and it was spinning thousands of times per second. So in the time that the laser would come in and it would hit the mirror, it would then start traveling down the hallway, hit the mirror at the far end of the hallway, fire back. This was a pain in the ass to line up, by the way. Fire back, and by the time it got back to that mirror, it had rotated, which means the reflection doesn't go off in the same direction. So by changing the speed of rotation of that mirror and measuring that angle, you can actually figure out the time it takes the light to traverse the length of the hallway.
Okay, I understand
that's how we did it anyways.
Light, basically.
I understand that. That's no big deal. I get that. How did Einstein do it?
Yeah.
He didn't have lasers, you know.
That's how I did it. I don't know. They actually did a similar. No, they did a similar experiment with this. Again, derived quantity.
You're breaking up.
On that, they could get a number because they knew the permittivity of free space and the permeability of free space.
Yeah.
So they knew what the number was. Again, just popped out of the math. So in some sense, it didn't have to be measured. I'm not familiar with the earliest measurements of the speed of light, though. I know they were based on a similar thing, but I didn't. It's been a long time.
No, let's keep thinking primitive, because that's where most people's brains are at. Is primitive, and
but if you can do that,
people on that level.
But I don't like that.
Weren't the original ones done similar to how yours were done, but they used half
the speed of light. Like when you do it in the microwave, and you have those little melted
light,
spots,
and they
right?
used half reflective mirrors, and they bounced them at different distances, and then measured the interference patterns, and then calculated back from that.
They did.
Yeah,
you're kind of breaking up. I'm not sure if it's your connection or mine, but
wasn't it done with interference patterns originally, Chad? They used
my connection's a Wi-Fi connection in a shed, so
yeah. Can you actually hear us now?
But,
you can. No, we've lost.
He's frozen. He's just.
I think so. Yeah. I think we're good. What were we talking about?
No, what I was saying wasn't the original ones done by using interference patterns. So using half reflected mirrors and using a different path for the directly reflected and the light that went through, and then you can measure the
using
pattern.
The half-silvered mirror you're talking about is called a Fabry-Perot device.
Yes.
I remember playing with those, and I can't remember the experiment that I did with them. It was something along that order, though.
Yeah.
When I was
there's a way you can use that to measure the speed of light as well. And you don't necessarily have to use a laser. You can just use a highly focused beam of normal light to do it as well.
Well, exactly. That's why I used the laser in that experiment. Yeah, with the mirror experiment, it was the same thing. I just wanted the laser to be bright enough, right?
And a laser is more accurate over that distance, but you can do it with just normal light if you focus the beam enough. So, but that's why our calculations for the speed of light are more accurate now, because we've got better equipment to do it with. But it's actually irrelevant now because we've defined the speed of light as a constant.
I see.
Because what we've done is we've made the meter itself variable so that the speed of light can be constant.
Yep. Because that's a fundamental property of space, right?
Yeah.
So if we're going to we want a measure of space, or as they would say in general relativity, a metric for space, you'd want one that...
Yeah.
I mean, it all makes perfect sense, but it's, I don't know.
It's kind of backwards.
Still kind of early for me.
Right, we don't want the speed of light to have to change every time we get a new measurement. So what we're doing every time we're measuring is we're getting the meter closer to being more accurate. And we've defined the meter as from the speed of light, and the speed of light is now constant. So the figure that we've got for the speed of light in textbooks will remain the same. But the distance, the actual length of a meter is going to vary slightly over time. Not enough that it's going to make any difference to anyone, but
yeah, the meter is now defined as like. Yeah, I can't remember exactly what it is, but now the meter is defined as 18 quadrillion BNUs of so many basically so many wavelengths of the transition of a very specific spectral transition in some element. I don't know exactly what it is, but somebody does.
How is it possible that...
That's modern education. You don't need to know the facts. You need to know where to get the facts.
How is it possible that a photon from, let's just say the Andromeda Galaxy, because I like the Andromeda Galaxy, it's kind of a cool thing. How is it possible that a photon from that can get all the way to fucking Earth and still have enough energy to excite my retina?
There's a lot of photons. Most of them don't make it.
Yeah. Oh, and quite often the photon that actually gets here isn't the one that left. Because each time that photon interacts with something in space, it can be absorbed and then re-emitted. So.
Well, I would. True, but we can more or less assume that it's the same photon.
Same photon, yeah.
I'm not sure if my voice is coming through clear now. Yeah. Mm-hmm. So when you're talking about, there's two concepts of light. There's this photon image of all these little BBs coming at you, right?
Yeah.
Or there's this idea of ripples in a wave. And when you think about like this wave kind of spreading out, and you think, well, it can't have the energy possibly. What you need to consider is that this is not actually a wave. Think of this as some distant object going crazy with an airsoft gun. Every single one of those pellets through space has a certain amount of energy. Otherwise, the entire intensity of the Andromeda Galaxy would be inside your eyeball, lighting it on fire.
Yeah.
A small portion of those things actually get there. And it's about every single one of those BBs individually has enough to kick the receptors in your eye.
And this is where we get down to quantum mechanics.
Needing so many BBs. Yeah.
Because a photon is...
So the photon nature of light is what saves it.
Yeah. Yeah. So because a photon is a subatomic particle, it's a little packet of quanta, basically. So it's a little packet of energy. And it travels along that metric that is space-time. So as part of... You're just dealing with a lump of energy that's moving through space-time. And it moves within that wave. That's the duality is complicated. There's lots of ways we can look at it. We can either look at it that it defines itself whether it's a particle or a wave, depending on us observing it, or we could look at pilot wave theory, which I actually quite like pilot wave theory, even though it doesn't solve some of the problems for us. Where the wave is actually an effect of the quantum packet of energy moving.
But what about the photons when Hubble's looking at a galaxy at the very end of space? You know, I'm thinking of that deep field image.
They've been stretched by the expansion.
You say there's a lot of photons.
No, there are very few photons.
That seems quite simplistic for the volume we're talking about.
Yeah, there's not a lot of
terrible.
There are a lot of photons that left those galaxies. Those galaxies are huge and emit an awful lot of photons. But the photons that actually make it to the detectors in the Hubble aren't that many. The only reason we get those really nice clear pictures is because Hubble spent weeks grabbing individual photons from that area of space. Weeks.
So I just had to go turn the heating down in here because it suddenly got the radiator next to me. It's either turn the heating down or do a gen.
You can strip. We won't stop you.
Nobody wants to see that. Nobody wants to see that.
We've lost Chad again.
Oh no, is he frozen again?
He's frozen again.
Well, he's in Canada.
Oh,
we've lost him altogether.
Oh, completely lost him. He'll be back. Maybe.
So how do we know that the light from Andromeda doesn't arrive here instantly?
You're going back to that one-way speed of light thing, aren't you?
Yeah.
He's not letting this go, is he?
He's not going to let this go.
Well, how do we know if it's how do we know if it's getting to us as a wave or a particle?
It's getting to us as both, basically.
Well, it depends. In pilot wave, no.
No, well, technically the wave is getting here as well as the particle.
Yeah.
If you're talking pilot wave theory, then your photon is the particle, and the wave is the what it makes in its motion within the fabric of space-time. So
yeah.
But you throw a rock in a pond, and the waves that come off of it lessen in their energy and intensity as their size grows. So
because
if you apply that to something like Andromeda at such a distance, I don't care how big it is.
It loses so much. I don't think you're anticipating just how much energy, how many of the photons are lost. I mean, when Jen said about Hubble, yeah, we had to look at space. We had to look at an area of space with nothing in it at all that we could observe for weeks, with photons coming in individually on the period.
Those. I mean, we're looking at photons from, again, the Hubble shot. They're coming in from 13 million, billion, trillion,
billion,
Google, whatever.
Billion. Like,
lots and lots.
Well,
of
about
years
96 million.
No, wait a minute. So now we're something closer like Andromeda, and those take a less amount of time to get to us.
Which is why Andromeda looks brighter. But
if there's all these that have gotten away that we don't see because of the beam spread, is the way to imagine it. Where are they?
They're still going.
Other parts of the universe, still going until they hit something.
The light that we can see from galaxies that are Andromeda, but galaxies that are further away, there is more light. The only reason we can see cosmic microwave background, for example, is that because it was emitted from every point, pointing in every direction. So the cosmic microwave background we receive today is from a different point in that initial thing as from yesterday.
Okay. I think I see the point that Jenny's trying to get to. Are you getting to why isn't the universe bright? Because we look out to the universe and we see that there's galaxies everywhere, but why are they dim when there's photons coming from everywhere? And the answer to that is the expansion of the universe, because the light from so far away has been so far shifted that our eyes don't see it.
Yeah. If you look in the microwave thing, it's bright in every direction.
The universe is bright in every direction.
I mean,
it's just not in wavelengths we see.
Because I know, with light or whatever, Andromeda Galaxy, it's like about 2.5 million years or something. Light takes to reach us.
Yeah.
When the light left that, humans were nothing.
We're not here. Yep. Our ancestors were.
They weren't human.
Those monkey brains.
Here's an interesting aspect to think of. Last time dinosaurs walked on the Earth, the Earth was on the other side of the galaxy and was looking in towards the Great Attractor, and to an area of our local part of the universe that has actually got more galaxies in it. So, on the other side of when the dinosaurs' night sky not only looked very different, we're looking up in the sky because there were different constellations, obviously, and everything. They also had more fuzzy things in the sky that were our galaxies that would have been natively visible because the side of the galaxy that the Earth was on at the time.
Okay, and here's another one. How stupid could the ancient humans have been to look at 3 dots in the sky and think that it's some guy holding up an object with a club and is beating the fuck out of it?
I don't think they did.
I don't see anything in Orion.
I think they just saw that as They saw the stars in the sky as representations of the stories that they told on Earth.
Oh, no, I don't even think it was that. I just think they needed something they needed to be able to identify it, and the stories helped.
Yes.
I think
also, the stars helped them remember the stories.
Yes.
Because if you can point to it, that's
it's also a sort of mutually it's a sort of mutual relationship, I think, with that.
They're there every night, and you identify the ones. I mean, the other thing as well is it's another one of those weird things we don't have now. It is virtually impossible for us to conceive what a night sky looked to them.
Oh, yes.
Because on a clear night, the scale of what they would see in the sky is completely different. They would see those 3 dots, but those 3 dots are surrounded by milk.
Well, for those of us who have been in actual dark sky areas.
No, it's not that we haven't, but it's every night. That's where you live.
Yeah.
No, I understand that, but what I was going to say is for those of us who actually been in dark sky areas, to you folks who haven't been, get your ass to a dark sky area and see it. You will not believe what the sky really looks like.
Especially if you're in the southern hemisphere and you can actually look back into the galaxy.
The first time I saw the dark sky, I was like 9 years old, and I literally went, you know, it was like, holy fuck! It actually feels like there's a ceiling over your head.
Oh, that's
that you're like in a room.
Absolutely beautiful in dark skies.
You got to see it. Make it a life project. A bucket
I have
list.
seen dark skies in both the southern and northern hemisphere, so I've seen both. Yeah. And I much preferred looking at the southern one, even though we can't see Andromeda.
How do flat earthers explain?
The breadth of stars you get in the southern hemisphere is so much better.
No, please, let's not go down there. Let's not go down.
How do they justify the north south flat different stars?
They say we're lying.
because
they can go see for themselves.
I know they can, but they.
Yeah, that's the fantasy they choose to live in, though. So, or the ones that really believe it, of course, because I mean, like I said, some of them some of them don't believe that. I mean, Oakley doesn't really believe the shit he peddles. Mark Sargent knows better. It's become, you know, it's become Mark Sargent's life now. It's become his income. He knows better.
Yeah, exactly.
He's lying.
I mean, I think Nathan Thompson, he's a true believer. You know, I think but
Wild Eden, the huge holes they're finding in the universe, billions of light years across, they're the voids we're talking about, and the argument at the moment is whether or not we might be in one.
Yes, because we appear to be in a part of the Shapley supercluster that is actually kind of sparse in comparison to other areas of the cosmic web. So,
saying that, at the same time as they're researching the huge holes that they're finding, they're also finding more and more ways to detect smaller and smaller amounts of hydrogen, and that seems to be everywhere.
Yes, so a lot of these voids are jammed packed full of matter. There is still a lot of hydrogen and helium within them. It's just that they haven't formed galaxies, or you've got to go fairly deep into. You've got to look back a long way with a lot of exposure times to actually see anything. So they're not necessarily empty; they just look empty to us on first observe.
It's so depressing and so lovely to watch
again, Ted.
A photo.
Have we got? Yeah, we got Chad back.
Maybe.
It's so depressing and wonderful.
I'm still having some internet problems, so we'll see.
Yeah.
He's junk shopping a little, but
well, you missed us. We settled the question about light and timing and photons. So
yeah.
Sorry, you'll have to wait for the paper to come out.
Yeah.
So we were just asking, answering question about cosmic voids. I love the look on Chad's face at the moment. Were we?
No,
not again.
Cosmic voids. You mean like Nathan Thompson's brain?
I have a question. Why can Chad not stay connected?
He's in Canada, in the boonies.
It's a 5G conspiracy.
I should point out we got a Canadian in the live chat here, Jenny. So keep off the Canadian jabs a little bit.
No, that wasn't. That's not a. It's a statement of fact. I live in Minnesota in the dark zones of the internet. It's the way it goes. Governments don't want to pay for this shit.
I'll leave the box up for him this time in case he gets back.
Both how wonderful it is and how depressing it is to watch a photograph of Andromeda as you just slowly let more light trickle in, because you can see it with the naked eye, but it just looks like
fuzzy,
nothing there.
And the thing you have to remember is most of the pictures we see of Andromeda aren't all of Andromeda. Like we know with our own galaxy and with Andromeda, the reach of the Milky Way, the external stars that it directly influences, extends a lot further than the core of the galaxy that we normally attribute to being a galaxy.
You can't see it. You have to block out the center.
Yeah.
You have to block out. To be able to see that, you have to block out half of it.
And if you do that with Andromeda and the Milky Way, the outer edges of the two galaxies are already colliding. They're already pushing in on each other, which shows how immensely large big galaxies are.
I hope we're insured.
There's only a couple of stars that'll get hit. Chances are it won't be ours.
Yeah, I mean, there's so much empty space even within a galaxy that it's unlikely that anything's actually going to collide with anything else. I mean, it may happen, but it's unlikely. Now, the more likely thing is you'll have some stars ejected and some stars thrown into the center of the galaxy, which is not so great because eventually they will get sucked into the supermassive black holes in the center.
What we will almost certainly have, though, is an asteroid, a comet.
Oh, yes, comets.
I heard that the heat generated by the collision would be so great that nothing on the planet could survive.
If something hit the planet, yes.
Yes.
No. The radiated space around whatever's happening to make the heat, that heat would be great enough, even at a distance, to wipe us out.
What are you talking about?
Okay. Shall we answer Sassy Heathen's question on do most galaxies have a supermassive black hole in the center? Depending on the size of the galaxy, most large galaxies do. Not all do. We know for a fact that there are some that don't. Some of them have lost their supermassive black hole at some point, or the supermassive black hole has migrated away from the center of the galaxy. But there are some that don't have it and don't actually have any signs that they did, which is even more amazing because we think having a supermassive black hole is part of the forming of a large galaxy.
We don't know.
A large galaxy that doesn't have one is kind of strange.
No, we don't know that. That's what Becky's researching at the moment.
Yes, it is. I realise that.
Because we don't know whether or not a black hole, a supermassive black hole, is a consequence of a galaxy,
or it's part of the source. Yeah.
Is a contributing factor to why big galaxies form.
Yes.
Which is why it's so fascinating, the ones without them.
Yes.
So it's really a question of the chicken or the fillet.
Yes.
There are some absolutely fascinating galaxies out there. If you want to go watch, watching Dr. Becky is so worth it. She is absolutely amazing, and somebody I dearly want to interview at some point. But there are galaxies out there called ring galaxies where they basically don't have a central core. They've only got the outer parts of the galaxy, which is the weirdest thing. It's like, how did a galaxy like that actually form?
But it's entirely possible something ploughed through it at 90 degrees.
Yeah, and pulled it and tore the center out of it. And there is signs with some of them that that's what's happened, but not for all of them. And it's one of those things where we see so many different types of galaxies out there. Yes, we have the really common ones like ellipticals and spirals and the smaller irregulars, but you also get other weirdly shaped galaxies out there, and we're not exactly sure what dynamics actually caused those to happen.
Maybe it was like on Star Trek, where they had that big thing that looked like a tapered cigar, and it was eating galaxies and stuff like this, and they blew up inside of it, and then it ends up blowing smoke rings that are galaxies that are shaped like smoke rings. Maybe that was it.
See. There's something. I actually there's definitely something I might have wanted to get for on my wall. Actually, I've seen this like a picture, and it is a picture of our galaxy.
No, it's
a
not.
depiction of our galaxy. It's a depiction of our galaxy, and then there's
How'd you
just
get outside?
and then just there's a little like little red arrow somewhere in it. It just says "You are here."
Mm-hmm.
I don't know. I just like that one.
In answer to
That keeps
Sassy's
moving,
other
apparently, so be
question,
careful.
does that mean that our solar system will be consumed at some point? Our
sun.
solar system will definitely end at some point because our star will go supernova and well, it will go nova when.
It'll
Sorry,
consume Earth.
it won't go supernova.
If it goes
We
supernova,
don't know if it will consume Earth.
I thought that was what we thought would happen.
We know the sun will expand to the orbit of Earth, but
Yes.
it will have lost X amount of mass by then. There's a reasonable possibility that the Earth's
Might
orbit
survive.
at that point in time will be much further out.
Yes, the Earth may survive that. But when the sun eventually throws off its outer layers, that will basically turn the planet into a little
Mercury.
ball of dust.
We're not surviving it.
Oh no, we're definitely nothing in the solar system is surviving that. There will be leftover bits. Well, Jupiter might. Jupiter's big enough. Jupiter
Yeah,
could conceivably.
we will have farmed Jupiter by that point.
Well, that's possible.
Technically,
Technically, we could farm our own sun and stop our sun from actually getting to that point.
Yes, I know. I like that idea.
I love the. I do like the optimism that you think we're going to be around long enough to have actually migrated out of this solar system. And
I don't. Well, yeah.
I think it's more likely
maybe I've just gotten such a bad view of humanity over the last few years that I think we are going to.
I think humanity will survive, but I think we're going to have a big adjustment in how we live at some point over the next 100 years, and there will be a major extinction level event.
I think we are going to go backwards
in the next 2 months.
Before we get
2 months. 2 months.
Wow, you're positive,
I give us
Chad.
2 months.
Give us 2 months.
Oh, good.
Waiting for him to say about
The
2
good news
weeks.
is, regardless of what happens, well, I don't. Honestly, people are going to be around forever. We're like lice.
Yeah.
We require very specific
I mean,
circumstances.
it can get rid of most of us, but we'll come back.
Yeah.
I don't think
myself
we're
more
going
as a
to wipe
dust mite.
ourselves out. Something else could conceivably
Well, exactly.
wipe
We're
us
not
out.
ruining the planet. We're ruining the planet for us.
Yes. Yeah, we're not ruining the planet. We're ruining the planet for us. And we as a species may still survive this. A lot of other species will not. But we as a species will probably survive this. How well we come out of that is the big question.
The planet belongs to the tardigrades.
Did you see, by the way, I think it was last week or the week before, reports of microplastics in umbilical,
Yes.
analysed umbilical material.
Oh boy.
And we're doing well with it. No, it's not.
Alright, I might start winding up
Now, the
because
good news,
doesn't
I will
Scientist
say
Mel
that,
start in like 15 minutes? Is that right?
I don't know. I went back to bed.
Yeah, I've
I'll
lost
check.
I'm never invited on that show.
Well, I might start winding up anyway. I'm at that point where my brain's not functioning properly anymore. So,
Well, I'm glad I was able to teach you guys something today.
yes. you often
Always
do,
a pleasure,
Jen.
guys. Always a pleasure.
Thank you, Chad. It's always
You
a
really
pleasure
do.
having you
Like, that's one of the reasons I come to these places.
to
One of the
share
reasons why I
knowledge.
love coming on and just
don't
talking with
think
people
she's.
is
I just
everyone
checked
has.
her. By the way, I just checked her Twitter. I don't think she's streaming today.
Oh, okay.
And I don't see anything scheduled on her channel.
It hasn't been scheduling.
Well, if people want us to keep going for a while, I don't mind. My brain's not as good. There's that Nature article for you in the private chat, Chad, in case you missed it when it was scrolling up.
Thanks.
I know, she said normal
my
service
internet
will be
is not the
reduced next week.
best, unfortunately.
But I think we've sort of come to an end of questions for tonight. Anyway, it seems like we've sort of got there anyway.
Okay.
Unless you got anything, anyone's got anything to add.
I've got one thing to say though, and it's about a comment that. Well, I've got one thing I would like to add to Jenny's earlier comment.
Yeah.
If I may. She was talking about it's a chicken and egg problem, and I hate that because lizards had eggs.
I didn't say egg. I did not say egg. I said the chicken and the fillet.
The chicken and the fillet.
Yeah.
Chicken and the fillet.
Because I know that you hate that. You've said that before, so I
filet o fish.
The
filet o fish.
I mean, that's an old one that we've. That's an old one. Anyone says to me the chicken and the egg thing, I'll say, well, there were species around that had eggs long before chickens were about.
Yeah, so the egg came first.
The egg came first. But the other argument to that is the chicken and the egg are lying in bed together. Chicken lights up a cigarette, and then the egg says, "Well, that settled that argument."
I love that joke.
Yeah.
That's very cool. All right, so
That's a good note to end on, I think.
Dave, you've got a full lineup this coming week, haven't you, with questions?
I have 6. We're starting 6:30 GMT on Monday.
Brilliant. I'm sure that everybody who follows Dave and will catch up with those shows, that they'll encounter some of us at various times during the week as well.
I'll have to talk
6
to you.
GMT.
I'll have to talk to you off stream, Dave, because there might be a thing. If there may be a date we might be possibly clashing. So I'll.
Well, they go all over. I'm going all over the place.
Okay.
Monday is 6:30. Tuesday's 9:30. Wednesday is 10:30. Thursday is 3:30. Friday is 4:30. Saturday is 11:30.
Friday, if it's Friday 4:30, that doesn't sound too bad.
Yeah. Basically, Dave's trying to make sure he can get as many of us as possible into shows over the week.
Yeah, that's a good idea.
Yeah, it is. It is a good idea. It's shocking for him, though.
6 GMT.
I will send you the spreadsheet, Jen, but I've got to send it to someone else first.
That's like midnight, isn't it?
Somebody else is getting first choice.
I think with 6 GMT, you are meaning 6 PM, right, Dave?
Yes.
Okay. You're not on 24. I'm sorry.
So morning for you, Jen.
About midday for you, I think, Jenny. I think.
Yeah.
Eastern 1:30 is 6.
Yeah. Stupid o'clock in the morning for me.
Yeah.
And Jeff, you have a asterisk tomorrow with Hissy.
Yeah, it's on Noodles channel. Yeah.
If anybody's curious, Nephilim Free's overdated.
Sorry.
Something's Nephilim Free.
Nephilim
exciting.
Nephi. That's a name I haven't heard in a while.
He's debating someone, is he?
Never mind. My internet's garbage. Disregard.
I'm gonna say I can't.
Apparently, I can't. 9 o'clock to. Yeah. 9
o'clock to somewhere. Okay.
All right. So yes, you've got a stream tomorrow.
Anyways,
we're on Noodles channel tomorrow. Yeah, and then we're doing Asterix and Sun. That's 1 PM UK time, so that's about 8 AM Eastern, I think. It's fairly late for you, Jen, I believe. I don't have this set in stone this week, but I think it's a good possibility. Next Friday, might be having Tim O'Neill on my channel. That's the website History for Atheists. So I think he might be. I think he could be someone interesting to have a conversation with. So So with it, hopefully next weekend, but we just need to actually get it set in stone.
Yeah. Brilliant. What are you up to, Chad? Aside from appearing on other people's channels and sharing your wisdom.
Whole lot of nothing. Whole lot of.
I'm sure people
basically
will
just hanging out on Twitter, sharing wisdom there as best I can.
I'm sure we will see you on my channel doing these science discussions again because this will be on again next week and it'll be after Dave's quiz, so people who've watched Dave's quiz can come across and join the discussion here. There's also for me tomorrow there's a facepalm factor. It'll actually be on my channel and not Jay's. Will and I and Jay are doing that. We'll probably grab in a couple of guests as well to be part of that. I have no idea what we're doing it on because we're putting it all together. But Jay asked to do a new one, but he didn't want to have to be the person organising or running it. So that'll be happening. That's tomorrow for me, but this evening for you guys. I think it's at 8 p.m. Eastern. So.
About 1 a.m.
And sometime tomorrow, Atheist Pastor's doing his first, and I can't remember what time it is, sexy Bible readings, like we did on Six Pack on Friday. So I don't know what's being read and who's doing it this week, but that's a thing that's happening apparently. Erotic Bible readings. Aside from that, Will and I are doing our What the Fuck show next Thursday. For people in the US, where we'll be discussing LGBTQ plus issues. Jenny will be on that panel, I'm assuming.
What do I know about that?
And yeah, like I said, another one of these next weekend, same bat time, same bat channel after Dave's quiz show. So please follow everybody and sub to them and make sure you catch out everyone's content when it comes on. Thank you all for watching and being part of it. Thank you to my guests who are absolutely amazing, and I've really enjoyed this discussion, and I think I've learned heaps this week. It's been good. So thank you all, and have a good one, everyone.
Thank you.
Bye-bye.
Bye.